Have you ever needed to lift something heavy, like a big rock for your rock collection, or the weights at the gym, but you were unable to because you were too weak? Luckily, there is a simple machine that can help you with such troubles. This is called the hand truck, and you have probably seen these commonly used in factories, or for deliveries, or even at school. They are used to make lifting heavier objects easier. Basic hand trucks have 4 key components: the handle, the frame, nose plate, and the wheels, which are not necessarily made of the same material. The idea of the hand truck is as simple as the following basic principles in physics. The lever principle in particular is the reason why the hand truck makes lifting heavier objects more easy. The lever principle works like this. Think of a teeter-totter or seesaw that has 2 equal length arms about the fulcrum, which it rotates about.
If you and your friend who weighs twice as much as you sit at either end, you would not be able to balance his weight. The force of his weight outweighs the force of your weight. But if the distance you are from the fulcrum is twice as long as your friend's, then you could balance his weight, and any greater distance will allow you to overcome his weight. Now, looking at the hand truck, we can see that the frame and the handles make up the effort arm, and the nose plate is the resistance arm. Since the effort arm is greater in length than the resistance arm, this allows you to lift a heavy load with a relatively small force and tilt the hand truck so that the load is balanced above the axle.
Now you can lift those weights that you couldn't lift before, and brag about it too.
So that's how the hand truck gets the job done. But where are they used? You might want to use one if you're moving to a new place, making furniture and other appliances easier to move. Manufacturing plants use hand trucks to move heavy equipment like fridges, stoves, and much more. And delivery companies use hand trucks to carry stacks of packages around.
There are more things to consider about the hand truck, such as the material it is made out of. There is a reason it's not made out of glass. The material used to construct the hand truck is very important and will determine how much weight the hand truck can move or support before failure. Nowadays, hand trucks are usually constructed out of materials like aluminum alloy or stainless steel because of their excellent mechanical properties and relatively low cost.
Multiple steps and processes are involved in the manufacturing of hand trucks. For a basic 2-wheel steel hand truck, the production process is as follows. First, a steel sheet is cut to form the nose plate. Second, steel tubing is cut and formed into the exterior portion of the frame. Third, crossbars that form the interior portion of the frame are stamped and pressed. Fourth, the axle and axle brace is made from round bar. Then, the component parts are welded together to create a hand truck without wheels. After that, the hand truck is cleaned and painted. Lastly, the wheels are added to make it a finished product. Different styles of hand trucks may vary in their manufacturing processes, but few are too distinct from the processes described above.
Let's say we want to determine the lightest material we should use to construct a hand truck. However, before making decisions about what materials to use, we should first consider the functional requirements. Under typical use, the center of gravity of the entire load is balanced above the axle, so that the user has to exert the smallest amount of effort. A typical hand truck is rated to support and move a mass of 300 kilograms. Because of the construction of the hand truck, we can say that the axle acts as a shaft fixed at both ends. That means that the axle must be able to support a 150 kilogram load at each end. The nose plate has to bear some load too though, especially just as the hand truck starts to tilt, the nose plate carries the entire load. That means that the nose plate must be able to support a 300 kilogram load without yielding, and also not deflect for more than a maximum of 0.5 centimeters.
There are a few things to consider. The material of the axle between the wheels and the material of the nose plate, which we will assume is the same material as the rest of the hand truck. The way to determine the best material that meets the criteria specified is by determining the Material Performance Index, or MPI, which is a single value that takes on all element properties into account. For the axle, the MPI value is different from the nose plate, and thus the rest of the hand truck, but essentially have the same objective, to minimize mass of the material used. For the axle, the MPI ratio is the stress over density ratio, and we want to maximize this ratio. For the nose plate, the MPI ratio is the stress to the 1/2, or square root of stress, over density ratio, and also E, Young's modulus, to the 1/3, or cube root of the Young modulus, over density. Again, we want to maximize these ratios.
After setting cutoff lines and further limitations on the nose plate, the materials that passed were various aluminum alloys. These are split up into 3 groups, the 3000, 5000, and 6000 series. Since all of these alloys had very similar densities, yield strength and ductility were the primary considerations. 5000 and 3000 series aluminum were not heat treatable and so only reached high yield strength through work hardening, which made them very brittle. Therefore, we picked 6010 aluminum, which had a relatively high yield strength and ductility. For the axle, both steel and aluminum alloys passed the cutoff and limitations. Although the objective was to minimize mass, steel was chosen as the most suitable material after some consideration. Since the axle is a relatively small part, the difference in density would not result in a drastic change in mass, but the steel provides a higher yield strength while not being brittle. Among the steels were martensitic, austenitic, and ferritic steels. Austenitic and martensitic steels were ruled out for having high yield strength at the cost of brittleness, and in the end, a ferritic AISI 436 stainless steel was chosen for its yield strength and ductility.
For aluminum, the H hardening process begins as the material is heated to a temperature which is above the solvent's temperature. Then, the material is quenched and heated again to a temperature that is below the solvent's temperature. For steel, the annealing process is initiated by raising the temperature to above the recrystallization temperature. After that, the material is cooled to room temperature.
The steps previously mentioned harden the material because of its effects on the microstructure development. As the temperature is raised above the solvent's temperature, the alloy becomes a solid solution, and once quenched, becomes a supersaturated solid solution. Then, when raised to a mild temperature, precipitates begin to form, which are responsible for the hardening effect.
Annealing is meant to remove the internal stresses in the material. At temperatures above the recrystallization temperature, new grains begin to form which replace the stress grains. To prevent any new stresses to be introduced, the alloy is allowed to cool slowly.
To conclude, hand chucks are a simple machine that takes advantage of basic physics principles. They have been around for over 100 years, allowing us to lift and move heavy objects beyond the strength of an ordinary human.
Thanks for watching.
Please like and subscribe.
And click the bell for notifications.